Okay. Let's just do some heap priority queue questions. Okay, let me turn up the brightness a little bit. Close some tabs. Close some tabs. We'll get along this when we get to it. Okay. Okay, you're given an array of integers stones where stones I represents the weight of the ith stone. We want to run a simulation on the stones as follows. At each step, we choose the two heaviest stones with weight x and y and smash them together. X equals y, both stones are destroyed. If x is less than y, the stone of weight x is destroyed, and the stone of weight y has a new weight of y minus x. Continue the simulation until there is no more than one stone remaining. Return the weight of the last remaining stone or return 0 if none remain. And so if you have 2, 3, 6, 2, 4, we smash 6 and 4 and are left with 2. So the array becomes 2, 3, 2, and 2. We smash 3 and 2 to get 1, so we get 1, 2, 2. We smash 2 and 2, so the array becomes 1. So there is only 1 remaining, and that's what we return. So if you smash 1 and 2, you get 1. Okay. Heap queue. Heap queue. All right, heap queue. So priority queue is heap queue dot heap pop heapify perhaps of stones, and while priority queue, the len of the priority queue is greater than or equal to is greater than 1, we do something and return if priority queue, we return pq of 0, else return 0. If none remain, and the priority queue, so heap queue dot heap pop of priority queue gives us some value stone, or we can be like stone 1, stone 2. And after doing all of that, heap queue dot heap, what's the heapify, heap pop, heap q dot, yeah, we'll see. So heap q dot heap q functions. So I don't remember the add one. Heapify, heap push, heap push, heap push, heap pop, heap push, heap push and heap pop. Okay, so you heap push to the priority queue some value, which is going to be S2 minus S1 only when S1 is less than S2, but what? If it's equal, then both are destroyed. So we can always assert that, so heap, this is a, oh yeah, so if it's a max or min heap, we have to consider. So in this scenario, we want a max heap. And the default, I believe, is a min heap. So I should check this just to make sure. And we'll just, we'll see what this looks like. Alright, so this isn't exactly how you should use this function. PQ is equal to stones. And you might just heapify the PQ. Although it doesn't matter, you know, it doesn't really matter how. And oh yeah, well, it should be up here. Okay, so 22634. Two, 634. Yeah, so it's a min heap. However, we want a max heap. So negative S for S in stones. Just make them all negative values. And now that accepted both test cases, but I think there could be something wrong still. Because what I really want is so S1 is going to be greater than S2. If S1 is less than S2, alright, we'll put the negative signs in front of these. It might be easier. If S1 is less than S2, I should not be less than, it should be greater than. Then it should be S1 minus S2. And if S1 is equal to S2, you just do nothing. And that would be fine. And so you add the negative of this. So what I did have was correct. It was just a matter of the negatives. But okay. So that would be the equivalent of what I just did, I think. Okay. Never mind, right? Because, you know, I still need to return negative here. That's interesting though. Alright, so that's accepted, but so is this. Which is if I did S2 minus S1 followed by removing this, changing this to a less than, and just doing it this way. This, I'm guessing this would also accept. No, it wouldn't. Yes. Okay, that's perfect then. Okay, if it doesn't accept, then yeah, that's good. Alright, we can revert. Because, yeah, it wouldn't make sense otherwise. Okay. Cool. Control all V. Okay, that didn't work. Okay, well that's probably because I need to actually just Control C, Control V it here. Okay, submit. That's interesting. You know, hold on. Yeah, there we go. Okay, it doesn't really matter. Yeah, it really doesn't matter. The lucky stroke. This problem is 1046, last stone weight. Okay, so that's fine. I probably need to also add a new note for this last stone weight problem. So last stone weight is a heap priority. I don't even have heap queue and priority. Priority doesn't matter. So heap queue max. So it's a max heap. We use a max heap, but remember the default of a heap is a min heap. And solved by myself, and we can paste the actual Leetcode problem here. We'll rerun this. And what else? I need to make mention of this in the boilerplate. So this is going to be after binary, so just before graphs.
Yeah.
Yep.
喝杯温水呢。
好，谢谢，谢谢。
试好了吗？
对，没事。
那大杯子不在这了。
So heaps. What is graphs? Yeah. Okay. The boilerplate here for the heap queue. So what do you call it in Leetcode? It's called a heap/priority queue, which fair enough. I will say we should remember heapq.heapify some function. Some list, and heapq heap push and heapq heap pop is what I need to use. I think that's it. Beyond that, everything else is pretty simple to understand. I'll do this trees problem that I wanted to try. I'll just reset this. Okay. This is the second Leetcode question today. See how much we can solve here. Okay, so is valid BST. Ideally after I do this I can get onto some other stuff. But okay, so it's just to ensure that the BST that we're given is valid. So you would return true or false. And I guess, you can think of this as doing a binary search. I know you can do this recursively. I can do this as a breadth first search. To verify that, the below is the same as the above. Oh, actually, before I do that, last stone weight this problem, I haven't even looked at the solution at all. Push and pop and heapify. Is this exactly how I've done it? It's close. You pen 0, I see. You can do it that way, sure.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem last stone weight. So this is an easy-ish problem, I would say, but we're also going to be solving the second version of this problem, last stone weight 2, probably tomorrow or the next video that I upload. So the context is that we're given a collection of stones. Each stone has a positive integer weight, so greater than 0 weight. And each turn, we can choose the two heaviest stones and then smash them together. Now, what happens when we take the two heaviest stones and mash them together? Well, in one case, if they are the exact same weight, both of the stones are going to be destroyed. If they are not the exact same weight, then the smaller stone is going to be totally destroyed, but the larger stone is going to basically be the difference between the weights. So, for example, let's say we had two stones, 5 and 4. This is the weight of the stones. They're not equal, so when we smash them together, the smaller stone, 4, is going to be destroyed, and the larger stone is going to be basically a 5 minus 4. That's what its remaining weight is going to be. We start with two stones, and then we get reduced to a single stone. The smaller stone gets destroyed. The larger stone is going to be 5 minus 4. That's a 1. So that's kind of what happens when we smash two stones together. At the end, there's going to be at most 1 stone left. And it could technically even be 0 stones if there aren't any left. So what do we want to return? We want to return the weight of whatever stone happens to be left over. If we don't have any stones left over, then we can just return a 0 as the default value. So I will say that this problem is somewhat straightforward. Let's take a look at one of the examples. And the reason this problem is straightforward is they gave us basically all the instructions and the information that we need, and all we really have to do is kind of simulate these instructions. We don't actually have to find a clever way to solve this problem. We just have to simulate what they told us. That's pretty much the best we can do. What did they tell us to do? They told us to always take the two heaviest stones and then smash them together. How are we going to get, suppose we had a bunch of stones like this, how are we going to get the two heaviest stones? Of course, we could sort the array. That's one solution. But even if we did sort the array, you'll find that it's a valid solution. But when we're taking the two heaviest, 7 and 1, we're smashing them together, and then we're going to basically be introducing a new stone, right? So 8 minus 7 is going to be the new stone, 1, and then we're going to maintain the sorted property of this list, we're going to have to insert this in order, which might be a little bit annoying, but I think it is a valid solution. But another solution is going to be a heap, not a min heap in this case, but we're actually going to be using a max heap because we're going to be taking the max stones each iteration. In order to take this input array and transform it into a max heap is actually an O of n time operation with the heapify function. But every time that we want to actually get the maximum from here, that's going to be a log n operation. And how many times potentially are we actually going to need to get the maximum from here? N times. So n multiplied by log n. That's what's going to be the overall time complexity of this solution. Now, how is it actually going to work? Well, basically, as I mentioned, we're going to simulate. So we're going to assume we have a max heap here. We're going to get the largest stone. It's going to be an 8. We're going to get the second largest stone. It's going to be a 7. We're going to smash them together. We have 8 and 7 smashing them together. 7 is smaller, so this is going to be destroyed. 8 is going to be transformed into a 1 now, so we can, let's just produce another 1 to this list. And we're going to continue the simulation, right? We're going to get the now 2 biggest stones. It's going to be a 4 and a 2. What's going to happen with 4 and 2? Well, 2 is smaller, so that's going to be destroyed. 4 is going to basically be 4 minus 2, which is going to be 2. So we can insert that into our max heap. So now we're going to insert a 2. Now we are left with, it's a little bit messy, but we're left with a 2, a 1, and a couple 1s. So when we smash these two together, we're actually going to be left with a single 1. I won't draw that because I think at this point you probably get the idea. Then we're left with 3 1s. What's going to happen with these 3 1s? Well, 2 of them are going to be smashed together, and then we're left with a single 1 left. And we have nothing left. We have no other stones to smash this 1 with. So when everything is said and done, we will be remaining with a single stone. So we can go ahead and return 1 as the return value. And it could have been a little bit different. It could have been something like, okay, we're left with 2 1s, then they get smashed together, and then we have nothing left. So then if we had nothing left, we could return a 0. But that's not the case. In this example, we do end up returning a 1, as you can see down here. This problem is pretty straightforward if you have a decent understanding of heaps and their time complexities. In this case, the only tricky part for us in the code is going to be Python does not actually have max heaps. So we're going to have to use a min heap to basically simulate a max heap. And you can do that by basically, assume we had some kind of heap, we would want 8 to be the maximum value, then suppose we had some other values, 3 and 5. But this is how a real max heap would work. But if we are actually implementing this with a min heap, it's going to be the opposite of this, but we still want 8 to be the value that we get from the root. So what we're going to do is actually have negatives. We're basically going to multiply every value in the heap by -1, so that the minimum, which is 8, -8 in this case, is going to be popped when we want the maximum, and then when we pop this, we're going to get -8, but we can just convert it, we can get the absolute value of this, and then just convert it back into an how unfortunately. Okay, so now let's get into the code. Like I said, we're going to be writing the simulation for this problem, and so the first thing we want to do is put all the, so now, we're doing it this way, but remember, we made all the weights negative. So what we actually have to do is the opposite of this case. If second is greater than first, suppose we popped, this is kind of an example. Suppose the first stone had a weight of 8, in that case, it would have a value of -8, and the second one had a weight of 7, and the value would be -7 in that case. Then of course, -7 is a greater value than the first stone, right? So that means basically this second is the smaller stone, and we have to
Hello, Zahib. I'm good, bro. Hope you're alright.
destroy second. And how are we going to do that? Well, basically, we already popped it from the heap, so we don't actually have to destroy it. All we have to do is take the difference between these two and then add that back into the heap. Now, how are we going to take the difference? First of all, a heap q.heap push is how we can actually add to the heap. So we're going to add the stones, whatever that value is. How are we going to get the value? Well, obviously, the value in this case would be a 1, right? If we took an 8, subtracted 7 from it, we'd be left with a 1. How can we do that computation? Well, basically, you can just take second subtracted by first. If that kind of confuses you, if these negatives and kind of that math confuses you, you can convert these into absolute values if you want. So you can take the first.
I feel as though I'm actually getting good with Leetcode now. I've the other day passed some of my Leetcode questions without looking at the solutions for the first time in a while. So that's pretty cool, pretty good. I think, it's a show of progress, I would say. I'm pretty happy with that.
And second, and convert them into the absolute value, then the math will be straightforward. I don't really want to waste too much time writing that code out, and this kind of does make sense to me, so I'm just going to keep it short and concise. I'm just going to take second subtracted by first, which will give us the weight that we want to add, right? We want to add a stone of weight 1. But remember, in our heap, we are keeping track of negative values, so I would have to multiply this by -1. The easier way to do this is just to take first subtracted by second, which will give us the exact same thing. It'll give us the negative value that we're looking for. It'll take the difference between these, and that difference will be negative, right? We'll have first, which is -8, plus 7, which is going to be a -1, which is what we want in this case. So I hope that makes sense. It's a little bit confusing, but basically this is our case, and that is the entire simulation code. Once we're done with that, we can go ahead and return whatever the value of the stone happens to be, the remaining stone. So stone at index 0. But don't forget, we actually do have negative values, right? So when we return the value of that stone, we want to return the positive value. So we're going to take the absolute value of this stone. And also don't forget one last edge case. What if stones was empty, right? What if we didn't have any stone left in here? Well, one way to handle that edge case is just to take, before we return, just say stones.append a 0. So in that case, if there's already a stone in this list, we'll end up returning that stone because it'll be at index 0. If there's not a stone, then we'll add.
That's fine. Okay. Bro, is it still cold in Oz? No summer? No, it's spring now. It's spring now, so it's coming through to summer. The house is so well insulated that I always wear this almost even in spring. When it comes to real summer, like, you'll see me a little different. For sure. Okay. So now we're going to do one more question. Going to do this one because I think it'll be a relatively harder one. Medium after all. Winter is starting there, yeah. And summer is ending on your side. Summer is starting on my side. You're cooked, Zahib. It's probably evening now, isn't it then for you? I'm guessing. Okay. So I want to try this in a number of ways, but I need to first validate it in my head. I want to do this first in a in a DFS manner, using a recursive structure, using a recursive function, and I want to also then try implementing it in a breadth first search manner using a while loop, if I can. So the while loop version would be check the first node, 2. Is the left and right of the first node valid? You know, does it make this node valid? If it does, move to the next nodes that need to be checked, 1 and 3. And if at any stage it is not valid, you would have to return false. What do you enjoy the most, summer or winter? I would say I enjoy summer more, just because winters can get really cold to the point where like my fingers are like frost nipped, and I don't like that. I don't like it. I guess, you know, that's probably a result of me not having proper heating in this house at home. So I prefer when we have proper heating. You know, if we did have proper heating, I think I would prefer winter more, but we don't. So yeah, right now I think summer is my favorite, and also my birthday's in summer. So there's nostalgic memories in summer as well. So I can definitely do this in BFS, but can I do this in DFS? Yes, I can. I would say, let's see. If I think of this in a DFS way, we need to check that 1 and 3 is valid before saying 2 is valid. So is valid EBST of the root left and is valid root right. And that's assuming, you know, you have both of these. Okay, I might just do it like this. So if is valid BST root left, if root left and is valid root left, and root right, however, or no. What's that, brother? What kind of keyboard is that? It's called the Glove 80. It's a split keyboard, ergonomics. It's for the ergonomics. Bro, have you tried Cursor AI? I've heard of it. I don't plan to, because I'm still trying to use less AI. But yeah. Bro, it's cool as fuck. Thank you. Yeah, it is pretty cool actually. I think it's got I forgot the exact name now of the keycaps. Well, yeah, they're in the description anyway. All right. So I want to do this in a depth first search manner. Not a depth first search. I want to do this in a recursive manner. I guess default should be true. Bro, did you watch the videos I told you? Which videos? I mean, those were a while ago now. So no, I haven't. Still, man, I still got lots of stuff to do. My bad, bro. Yeah, no, I still got lots of stuff to do. It's not on the list of things on my mind at the moment. I'm sorry, Zahib. Okay, so is valid. You check that it is valid. If at all it is not valid, alright, then you would have to the thing is now there is no part in here where we do say it is false. If root left and if that's false, then you would... Okay, so I need to put this in a if statement below it. So if root dot left so root left value is less than root value, then we're good to check the below. Else we return false. Is valid is false, sorry. I think there's something I'm still missing here. Bruh. Bro, are you trying to get jobs in Fang? I'm trying. Yeah, you can say I'm trying. But I'm still studying. And thanks for the compliment, copy multi. English. I don't think this is entirely correct, because if this is false, we want to return false straight away, I think. Else we return false straight away. I think that's what we want. We'll try. So one of them worked, the other didn't. Okay, so I forgot that you need to do this. Okay, so that's past the 2 test cases. I'm gonna have wrong answer for sure, 5, 4, 6, null, null, 3, 7. So if I redrew out this graph, we're probably gonna get 5, 4, 6, nothing, nothing, 3, 7. If I iterate through each of these, so is value true, is valid is true, node left, yes. Node left val is less than ooh, hold on. That's right. So 5 is less than 4 but greater than 6. So is greater than 4 but less than 6. 4 itself has nothing underneath it, so that's fine. But 6 has less 3, 7 greater, right? Thanks, man. What is your plan after it? Like, get a job in Fang and that's it, or any other plans? The thinking is, I'll work at Fang for a bit, maybe 2, 3, 4 years. As long as I can, really, and as long as I can deal with it. And then what I'll do is perhaps just do the stuff that I want to do. So there's like, startups that I want to eventually get into. Well, not like actual startups like right now, as in like existing startups. I want to build something myself. So I want to build something from scratch. And part of the thing that I'm doing right now on the side, the scheduler app that I'm building is partially something on my mind. 4 years down the line, I don't know if I'll still have that on my mind, but if it's not that, there'll be something else. So, the plan is to get capital, build something out myself, and, that's like the main plan. And if not, maybe I'll do something related to a PhD. Yeah, get money, get the experience, and then build your own startups. That's the plan, yes. Copy multi. That's all bro needs, actually, a GF. Bro, what you saying, huh? Yeah. I only passed half the test cases here. For good reason. Because the way I'm currently doing it, not necessarily the right way. I'm just checking that at each step, one has to be less than 2, but I'm not checking, say, a layer deeper, which is 1 has to be greater than 2, but say less than 0 or greater than 0. Bro, I see a lot of dudes like get in Fang and work for months or 1 year and then leave it. Yeah. Like, I'm sure it'll take a mental toll on you at some point. You know? Sometimes you find that there are better things in life than just working at a FANG job. And after all, you're there for the credit, for the credibility. Yeah. Sometimes you can get overworked. That's it. So say then, let's do the example of the test case that we have here. Because this is a test case that I failed on. It'll just be another condition that I'm missing, just a little bit of a condition that I'm missing. So 5, 4, 6, nothing, 3 and 7. Hey, are you from Australia? Yes, I am. And bro, is that an M1 MacBook? Yes, it is. Yeah. It's the baseline of the baseline MacBook. So I actually did a factory reset the other day just to get rid of like a lot of junk. Now the SSD is 38% used. Before it was at 99% used, like 90% of my time using it. It's just the M1 base model, so M1 Air. It's the baseline of the baseline. We're talking it costs as much as just an iPhone 13 or iPhone 15. Okay, so 5 has to be less. 5 has to be greater than 4. 5 has to be less than 6. 6 has to be has to be greater than 3, but 3 has to be less than the parent, 5. So maybe then I can't do this recursively well, at least. Alright, let's try the alternative. That being a DFS. We're going to reset the code. We're going to go DFS. A BFS, my bad. Okay, I keep on saying the wrong things. Okay. We're going to use a queue. So collections, DQ, with the root value, while queue is not empty. Q dot pop left, because we're going to do a depth first. This is going to return us the root node. So yeah, air models are great and cheap, bro. How did you got the idea to live stream the whole process until you get a job? What do you mean, how do I got the idea? I just decided to do it, Don't know how well, it'll turn out in the end. But it's a good motivator, to be honest. So I think, it's definitely helpful for me. Hopefully it incites others to be as productive as well. Or, at least can join me in the process when I'm doing it. By all means, you don't have to, but that's what I'm also trying to be here for. To help others also just want to grow, I guess. Okay. Node. node val is what I need. And at some point we want to q.append a new node. So it'll be either node left or node right. Thanks, Zahib. Let's see. Q append node left. Only if node left exists, firstly. And if node right exists, then we can also add that. You know, with all this, the problem lies in the fact that you need to keep track of the value. So when you need something else with the nodes, and that might just have to be the current node value. So the root with the root value when you have this, you can do the same thing here. Bro, is that a green screen or BG removal filter? It is both, actually, but mainly a BG removal filter. I actually had to use like a little bit of a trick. So it's a BG removal filter, but it's like built into the Apple app, right? So this is just Apple functionality that you can use with a camera that they have, you know, like an iPhone. And what is it? So if I go up here, you know, iPhone camera, you can change the background, right? So this is what I'm using. And you see that it's green here. It's because that's the background that I've made it into. And so if I go to the camera, you know, I then put on a filter on the camera in OBS with a chroma key. So this is what it looks like. And then I just use the chroma key. Yeah. So you're just using iPhone for the camera, yes. This is the iPhone 16 Pro. We're talking, yeah, I just got the latest one probably last week. And so that's why you see my, I guess, change in camera view since the last time you've seen me. Okay, so node, and this is going to be the prev. We're just going to call it the prev val. So then we can make some checks. So if the prev val is greater. Okay. So node dot left has to be less than node val, and it has to be greater than the prev val. Is that always the case? Because if you're checking, then something's not entirely right? So if you check this 3 for sure, that'll be correct. But if you check this 7, so you also need an idea of exactly which side you went down. You know, if it was the left or the right. In that case, you should also add node val, node, I don't know, maybe we'll say 0 for left, 1 for right. Or should I just say right and left? Okay. That means we also need to keep track of direction. So left less than node val. So if direction, let's see. Is right, and you go down the left. You go down the left, node val. And node left is greater than the previous val. Then that 6 is good on the left side. For the right side, you got 7. I'm definitely overcomplicating this, I think. But, you know, we'll see, and if I really can't figure this out, we'll go to the solutions. So 7. So and node value is greater than node.right.value. Sorry, is less than. Is there any other check? Then you would return true. Or you would continue. And if direction was the left, Alright, say let me just flip this tree, right? If the direction was the left and node right val is less than, would be greater than node val, okay, node right val is greater than node val, and node left, node right val is less than prev val. Is that right? Prev val. Let me change these. Maybe you got 3, 4. Maybe we'll just change this to 6. Just don't look at this side altogether. Change this to 5. You have the left side. If this right node is greater than the node, and the right node is less than this node, we're good. Whoops. And node val is less than, is greater than node left val, we would also continue. Okay, but increase the size of capture size of the hand cam. I'll make it a little bigger, I guess. See. Hope that's okay. Just losing focus a little. That's right. Whatever. I think I would say this, right? I would put that there. Let me think. No, this is under the assumption that node left and node right exist. Okay. So left node right. What should I say here? Nah, this is overly complex. Alright, we're good. This is overly complex. I think we should just look at the solutions here now. Zahib says, bro, did you reach 100 work PM mark? No. Not for this keyboard. Not for, what's it? So, monkey type. Not for coding. I can show you the current WPM. Ah, man. That's not bad. So 42.95. How do you get this code typing test on monkey type? Yeah, it's actually pretty easy. Everyone's been asking me this, but you just go to code. So on this language global symbol, you can just, you can pick English, you can pick whichever language. You can also just type in code and pick any coding language as well. Vim, TypeScript, whichever you want. Alright, see you later, copy multi. Thanks for joining. Yeah, JavaScript's even here also. English. Of course. I missed on the very last. Bro, do type very sensitive monkey type? Nah, not right now. I'm good for now. Just change it back to code though. C++. I'm good for now though. Let's gotta get back to this one. This question. Sorry, this question. Gotta see how this is done. So binary tree, binary search tree, and depth first search. Okay. Okay. Okay, so you define a valid function. Interesting. All right, let's see.
Hey everyone, welcome back, and let's write some more neat code today. Solving validate binary search. A very good question for practicing binary search tree questions. We're just given a root of a binary search tree, and we just want to determine, is it a
Bro, did you learn React and Next.js? I've learnt React and Next.js in the past, yes. You know, sometime this year ago, I did. But yep, haven't done much of it since because uni.
Valid binary search tree or not. And from learning data structures and algorithms, you might know that a valid binary search tree is such that we have a node like 2, and every single node in the left subtree, 1, and if it possibly had other children, is going to be less than 2, right? So 1 is going to be less than 2. And similarly, every single value in the right subtree, 3, including 3's potential children's, if it had any, are going to be greater than 2. Not greater or equal, strictly greater. And we know this is a recursive definition, so if we had 3 and it had some children, like 5 and maybe 4 over here, we see that it's not a binary search tree because 4 should be less than 3. 4 should be less than 3, but it's not. So this is not a binary search tree. So
Okay. Bro, make a video on a day in the life of yours. I mean, to be honest, this is a day in the life. You know, my like legit 7-hour streams, that's literally a day in my life. Nah, okay, I mean, I'll consider it. Not sure if many people would be that interested, to be honest. Not sure if it's worth the hassle.
So we need to do a recursive depth first search to solve this problem, but let me show you what you might try. You might just try a simple solution like, hey, 5, we have 5 as the root. Let's check its child. Okay, 3 is less than 5. That's good.
Mm-hmm.
Okay, let's check the right child. Okay, 7 is greater than 5. That's good, right? Okay, now let's check 7 because we see 3, it doesn't have any children. That's good for us. We don't have to check anything. But 7 has a left child. It has 4 as a left child. Well, that's good. 4 is less than 7. And it has a right child, 8. That's good. 8 is greater than 7. So is this a binary search tree? The answer is no. Because it's really easy to miss. We have a 5 as the root.
That's what I missed.
We have a right subtree over here. And we have a 4 in the right subtree. But we know 5 is not less than 4. That's not true. So we need a better algorithm, and it requires depth first search. We can't just check the neighbors. So our brute force approach would be for 5, check every value in its left subtree, make sure that every value is less than 5, and then check every value in the right subtree, make sure 5 is less than every value in the right subtree. And so we would need n comparisons to do that, right? O of n. And then we'd have to repeat that process for every subtree. So 7, we got to repeat that, compare it to every potential descendant of itself, which is going to be O of n. And the time complexity of that overall is going to be O n squared. So can we do better than O of n squared? So one thing to notice is the root value can be any value, right? There's no restrictions on what the value can be because it doesn't have any parents. So we can say that it can be any value between negative infinity and positive infinity. And as long as that's the case, 5 is okay. We don't have to make any other comparisons. 5 is between negative infinity and positive infinity. Okay, and then when we go down to the left subtree, we know 5 is good. We don't even have to check it anymore.
Which software are you using to connect your iPhone camera's webcam? Literally, it's just OBS. OBS has, well, technically it's continuity camera. So because I have an iPhone and a Mac, they can connect together easier. There's no other pieces of software at all. Yeah.
But when we go down to the left subtree, what do we have to check? All we have to check is that 3 is less than 5. So in other words, we just want to make sure 3 is greater
Between-
than a negative
Oh, man, I
infinity, which
should've-
of course it is.
Yep.
And we're adding one more condition. We want to make sure
It's greater than 5.
less than 5.
Less than 5.
So our left boundary stayed the same, but we had to update our right boundary from up here, right?
Yep.
And so we're done with that. And of course, we don't have any children for 3 and 5. Of course, we don't have any children for 3, so we are done checking 3. Next, we want to also determine that the right subtree is a binary search tree. So we want to make sure 7 is greater than 5. But is there an upper boundary for 7? Like this could have been 100 or it could have been anything. So there's no upper boundary
No
yet.
upper
So
boundary,
we just need
no.
to check that 7 is less than infinity, meaning that this is the right boundary, and it's greater than 5.
Yep.
So we had to update the...
So that's what I've been trying to achieve, but I achieved it in a very convoluted way so far. Okay, Zahybe says, DSA or Dev, which do you enjoy more? To be honest, it would be, they both are pretty nice. Like, DSA feels more important sometimes than Dev, but also Dev sometimes feels more important than DSA. It really depends on, I guess, my mode, my mood and my mode of thinking at the moment. If I'm doing stuff out of uni, I would probably, like, if I wasn't at uni right now, if I wasn't doing any uni work, I think I would just prefer building projects just like you. But I think, when I'm at uni, you're mainly told to learn about concepts, and well, DSA is all about concepts. So even still, I guess there's a time and place for everything. I wouldn't say I like one over the other.
left boundary over here. When we went here, we only had to update the right boundary. And this condition is true, so we are done checking 7. It is satisfied. And when we go to the right child, 8, we're going to do the same thing. We only have to update the left boundary, so we have to make sure that 8 is at least greater than 7, but it could be anything, so it's less than infinity. So that's good. 8 is a binary search tree, but now we get to the value that actually breaks our binary search tree, and let's see what our algorithm does. So we know, since 4 is the left child of 7, it should be less than 7. 4 is less than 7,
but greater
we have
than
to
5.
update the right boundary for 4, but the left boundary stays the same. So we're getting the left boundary from over here. We're borrowing it from its parent, because if 7 is greater than 5, then its left child, and 4 is a part of the subtree, 4 must also be greater than 5. So the left boundary is 5. Now, does this condition hold?
No.
It does not. 4 is not between 7 and 5. So this value breaks our binary search tree. So therefore, this is not a binary search tree. It's false. We're returning false. And with this algorithm, since for each node, all we're really doing is making a comparison, we're making a single, or rather 2 comparisons. This is going to be big O of n, or 2n, which we know is still linear. So we can just call it big O of n. So now it's actually time to write the algorithm.
Okay. Zahybe says, but you have to do DSA to get a job for big tech, but no for small, mid-sized startups. Yeah, that's true. That's true. But I guess, I guess what I also feel as though is that if I don't do DSA, I'm just missing some sort of opportunities as well, obviously in big tech, but also, I want to be able to say that, I did some sort of big tech experience as well. So, that I'm well-rounded as a person, and perhaps, it'll be useful for me if I ever want to claim that I am a person from big tech or whatever. Not that really I like names, putting names to things. labels, but you know, it gives me the opportunity to. Anyway.
Rhythm and the
Okay, so I want to try and build this algorithm. Do I? I mean, I did spend some time already. Now that I know how to do it, okay, maybe I'll see how he does it and then I'll do it myself.
best way to do this is recursively, so that's what I'm going to do. I'm going to write a helper function nested inside of this helper, or inside of our original function. We'll call it valid. We know we need to pass in the node since we are going to do this recursively, and we're going to have two boundaries, left and right boundaries. Like any binary
This is
search
completely
recursive
very
function,
simple.
if we reach a null node, we can just return. What are we going to return? We're going to return true because technically an empty binary search tree is still a binary search tree. And then we want to check, we want to make sure that node value is less than the right boundary and node value is greater than the left boundary. But we know if this is not true, if these conditions do not satisfy, then we have to return false because we found a node that broke our binary search tree. And now it's time to make our recursive call. So we want to make sure that the left subtree of node is valid, so we can pass node.left. And what's going to be the boundary for these? Well, since we are going left, we can leave the left boundary the same, but we're going to update the right boundary to the node's value because we know that a left subtree has to be less than every value. We know every value in the left subtree has to be less than the parent. And so the parent is going to be set to the right boundary because we need to make sure that this is going to be less than that. So we want to make sure that the left subtree is valid. We also want to make sure that the right subtree is valid. And in this case, we're going to do the opposite of what we just did. So the left boundary.
Yeah, the rest is pretty simple to understand. Okay. Perhaps I want to do this, you know, DFS using, or do I, okay, I want to try BFS at some point again. If I do it in BFS, you got to pass in your bounds. If you got to pass in your bounds, you then check if not node, return true, and the left and right of this node value, return false. Yeah, before I was doing a check on both the left and right of this node, when I could instead just do it on the node itself, which saves a lot of more conditions. Okay. All right, let me sit down again. So do I know about top towel? No, I do not. I haven't heard of that before. I will not check it yet, not now. But I'll keep in mind. Okay. Okay. Oh, it connects the top 3% of devs died playing clients? Okay. That's nice. Are you using it? And you have to clear out the different rounds like DSA round and then dev round, more things to get in. It's pretty much hard to get in, yeah. I wouldn't be surprised. I wouldn't be surprised. If you want top quality devs, that's what you gotta do if you want to maintain that. Yeah, I'll check it out. I'll check it out later. Possibly after I finish just this Leetcode question. Okay, so node val has to be less than the right left has to be less than node val. If not this, turn false. Otherwise, return valid of node with node left. So you check the node left and node right. If you go node left, then you have to update the right value limit and keep the left. And so this and valid of node right of node val and right. But if you get in, you can make good amount of money, like in big tech devs have worked in there and they are featured on homepage. I see. Yeah, okay. Alright, well that was accepted. Interesting stuff regardless, so definitely, you know, I want to attempt this question again in the future, so oops. Let me just quickly write this down. I'm going to star this. Go to valid binary tree again. I want to copy all of this. Yeah, Control C, I guess. Control all, Control V. Submit. Alacrity. NVim. '98 validate binary search tree. .py and paste this solution. Okay, and I've got to make a quick note on this. So this was to use a binary search tree. Using DFS. I'm sure you can use BFS. Although, you know, I'll just leave it out for now. And we're going to say, you know, had to look at solutions to solve this problem. It was much easier than my first two attempts using both a recursive and a iterative approach. Okay. A trick to keep on top of is knowing when to add nodes, process nodes, for the sake of simplicity. So, for example, you know, there is the scenario where you do something like, whoops, actually no, this is something I don't want to do. Okay, say you have, I would say the boilerplate. Perhaps this is the boilerplate. Could be instead could be instead if node, if not node, return true, and you just append node left and append node right. So like this is something that I'll have to consider doing instead. And you know, this is I might even write always consider alternative approaches such as discussed in validate binary search tree. Alright, so that should satiate my desires there to write information, okay? That's the heap queue. We can already know this works, yes? And we have understood that now. and top for top talent, right? Yep. I'll just turn this color off. Now you see, this is where I will eventually be if I get into big tech. That's the hope, you know? Like, platforms like this exist. Hopefully, for me in the future. You know, once I've become big tech, once I've, you know, had experience like these guys, you know, then we're gonna be good. You know, the thing is, like, also, these people, if you look at all of them, they all look like they're in their, you know, 30s or above. To which case, you know, they deserve to be on this platform, you know? Oh, hello KFC. Thanks for joining. Yeah, right. So some of these also made startups. I wouldn't be surprised at all. Like, these people are pretty, I would say, mentally able. So I wouldn't be surprised at all. Designers, financial experts, PMs, marketing experts. Yeah, these are good. These are good for the big names. Yeah, I mean, this is what it's, this is good. All right. You can apply as a freelancer. This is risky. This is risky. I wouldn't do it yet. Okay. Alright, I'm done for now. I will focus now on some study. So, Leetcode, we're done. Half lecture, I did this already. We really need to focus on a few things, but I need to focus by setting some of these aside. So this is one of the things that I need to do. We had a look at this. Oh, even if you get rejected, you can't apply for the next 6 to 12 months, even if you make a new account because you have been gone in the rejected list or something. Yeah. Makes sense. I mean, the thing is, even if I did do it now, I think it'd be a waste of my time, but also, even if I did, 6 to 12 months, I'm not even going to say I can get there by 6 to 12 months, you know? This will be a lifelong journey. To definitely not like something I can complete in a year, to be honest. Because I'm not there yet, I don't think. I wouldn't say I am. You know? Yeah, this is right. I would say it's no joke. It's no joke. Okay, so these two things I need to move off to tomorrow again. But ideally, right, I need to get this done. Hopefully I can do some, as much as I can today. So why is this important exactly, right? Why is presentation slides due so important? It's because I need to build something before then, right? So like a baseline implementation of something. And the problem that I have right now, now we're fine, okay? Just checking, why is there a lot of downloading occurring? I can justify the uploads, but not the downloads. The other thing is I did a backup. Just gotta check how these go. It's an hourly backup, which I'll keep it as hourly. It's alright, it's good. Okay. Alright, now we're going to be talking about cryptography. So we can close these two and we can worry about cryptography now. So I just learned about polynomial rings. Okay, now polynomial rings, I'm still getting my head around it. I'll need to do some examples, but that's beyond the concern at the moment. The main concern is to build out an X3DH algorithm. So maybe, perhaps I will write this, I'll change the title of this stream. Harder. So, assignment 2. Oh, wait, this is completely different. X3DH. This is the main thing that I gotta work off. So, this X3DH algorithm, I'm gonna turn down the brightness here and then turn on light mode because, you know, I'm gonna be working in light mode. And my eyes are gonna be strained to no end. But I'm turning down the brightness on my end. Whoever's watching, I hope you guys turn down yours. Okay. Oh, give me a sec. There's something wrong with our robots. Okay, first, this watch needs to be charged. I'll be back in another second. But I also need to first set the robot to vacuum different rooms of the house. Okay, it's gonna go a variety of places. Alright. Go back, just gonna put this back. Okay. So. Okay. VS Code. Light mode. VS Code light mode. Oh man. So I've set up each client to have a name, an identity key, an ephemeral key, a signed public key, and one-time public key. Sorry, it's not public key, it's pre-key. So one-time pre-key and signed pre-key. You know, these are all interesting. But a client has all of these keys. And at the end of it, they also need a master key, MK. And this master key, we'll just for now just say keep here, to be honest, but we're going to change this. So a master key, a one-time pre-key, a signed pre-key, Alice's identity key, So the curve parameter though is an application using X3DH must decide on several parameters. Okay. So what defines an application, right? Concatenation of byte sequences. An elliptic curve Diffie-Hellman involving the key pairs represented by public keys depending on the curve parameter. Yep. Involves three parties, Alice, Bob, and server. Yep, and then identity pre-keys to a server. Alice fetches a pre-key bundle and uses it to send an initial message to Bob. Bob receives and processes Alice's initial message. The following section explains these phases. Sure. And then you can see you have security considerations. Key compromise, identity binding, interesting, and you got references. Okay, so this is not bad at all. Like, this is not bad at all. A few things that I do notice is that we need the algorithms for signing a pre-key and a KDF algorithm, as well as a Diffie-Hellman, elliptic curve Diffie-Hellman. So, you know, these are things that I got to check out. But if I were to say contextualize this in terms of what does what, it would have to be on the client, right? It would have to be on the client. The client is the application in this case. So under that assumption, let's move on, right? So an application using X3DH must decide on several parameters. We're saying the application here is going to be the client that we have here that we have identified. So with the client, we must define a curve, a hash, and an info. So we're just going to say, you know, self dot curve is yeah. The problem is though, you know, we're going to make this also an enum, perhaps. So Python enum is something that I want to maybe search up. Okay, so we're going to set up an enum. And we're going to say, you know, one of the classes is curve x 25519 is equal. Ooh, is that is equal to 1? Enum 0. And x 448, okay, is equal to 1. One thing I got to do also now is charge my phone because it's already low battery. Okay. Should be on charge now. Let me double check. Yeah, it's charging. Okay. Cool. Um, oh, we're going to set a default curve to X3DH. Ooh. So the name has to be info, right? String specifying the application. Eek. So maybe I need to make that separate, make that completely separate. So self.info is an ASCII string which identifies the application. I mean, it could be Alice. I suppose I don't know where info is being used for here or how it's being actually useful. So I can't do proper checks here without opening the specific research project specification for X3DH. We search for info. 1 of 19, 2 of 19, so info. So info is used in the KDF. I think that's only where it's used for. Okay, so it's only used for... I guess the protocol, it has to be the same for both parties. So in this case, we might just call it my protocol. So if I set the info parameter to some string, this will have to be my protocol. And I want to just not use I need to get Python linting. Damn, I don't know how to do that. Alright, but we got to do some Python formatting. So if I did format document, like what is that using? Okay, Python formatting. Pylint, flakate and black. Okay, so... Ooh. So, I mean, this is a pretty good resource. So I'm going to just follow along here and see how much we can follow. I will say that, you know, this page I might just keep like this. Okay, and we're going to use the terminal here and say, well, you know, we're going to have a requirements file that contains pylint flake 8 black so pip install pylint main.py, so it'll be in src main.py. Unused import errors. So there's quite a few errors. Alright, I'm gonna sit again. Bro, drink some water. Okay, you're right. You're actually right. Why though? Why do you say that? Okay, pip install flake 8. Bro, do you go outside and take sunlight? Yes, I do. Shockingly. The sun is actually pretty good today, so I'm gonna go to the gym, you know, later in the afternoon. So we're fine. We're fine. Leetcode done? Yes, Leetcode is done. We're doing other stuff now. This is for a project that I need to build. Got to build the X3DH algorithm. There's no select linter. You. Missing class docstring. Perhaps this is unnecessary. Do you know Mark Liu? No, I do not. Is he, I'm guessing, competitive programmer, to be honest. Knowing user hype. Okay, Mark Liu, I'm guessing now this is now a web app thing. Alright, fine. I'll have a look at his name. But nothing else. Okay. Oh, I see. Ship fast. Solo entrepreneur for sure. And he's just sharing how much he makes per month. Damn. Hmm. So he also has a YouTube channel, fair enough. Let's have a look at what this guy... I'm sure he's pretty successful. Yeah. I mean, he's got the algorithm, the very YouTube algorithm type stuff. Won't lie. I saw the max earning on ship or what? I mean, isn't it just this per month? Maybe not. Maybe not. I mean, fair enough. Alright. And another guy called Levels.io. No! Alright, yeah, I believe he probably does the same thing. Yeah, I'm not looking anymore though. I believe you. Recommit hooks. Okay, pip install pre-commit. So firstly black this. I mean, you know, these people that make those apps, you know, very good. Like, I have full respect for them for doing it. It's just sometimes I don't think I would even do it for myself. If I knew of something, I'm not that into the weeds of like the trends, you know, like I feel like these guys would know their shit, but not me. I don't think I will ever be bothered beyond personal wants and needs, unless they're so obsessed with, you know, these getting money. Maybe that's part of their belief system. That to me, you know, it's not really that important. Anyway, I don't know. We're talking about politics now. But these guys, you know, I have respect for them for grinding out, building out these things that are valuable to people. Yeah. Now these guys learn programming themselves and built their own SaaS. Levels I expired. Okay, yeah. Fair enough. Levels I expired. Check it out. I'll check it out later. I won't check it out now. I'll check it out before I leave. The thing is, I need to make lunch in just a bit, so I'm thinking whether there will be a period of time, possibly like greater than 2 hours, that I don't know if is worth streaming still. You know, we might end up we might have to end up like splitting the stream into two, is what I'm saying. For today, at least. He was fired. I see. Well, it seems to turn out well for him, you know? Okay, we got the vacuum cleaner going around here now, so it might be a bit loud. I apologize. I hope it's still bearable. And then he built 23 websites from software habit strikers and the AI tools, and he does everything himself from the code design and the marketing. Yeah, you know, like these people, yeah, they're good. You know, there's a level of obsession as well. And they can probably do all this because, you know, they ended up becoming unemployed at some point, and made it good for themselves. So I'm not surprised, and you know, it just shows what a man can do if they dedicate their whole time during the day to do it. Like for me, at least, I still study, gotta finish those, and if I become unemployed, like you bet that I'm gonna be like one of them. Hmm. Yeah, you can do anything if you're young and want to achieve something in life. Yeah, you know, that's what I think. That's what I think. Okay. Where is it taking black from? Oh, what's the background sound? It's the robot. It's just vacuuming the house. Yeah, I know it's a constant hum. Hope that's not. If it's annoying, tell me actually. .8.0. There's a feature on iPhone 60 which mutes the background sound and focuses on your voice. Oh, yeah. Let me just see this one. Okay. The thing is though, I'm using a microphone. If it wasn't already obvious. Yeah, there's a microphone here, right? That's picking up all the noise, but like, yeah, there's a voice isolation mode, but this is for that specific, yeah, I don't know if it'll be better at all, to be honest, so I'm not going to try. Actually, should I? I mean, I can't be bothered configuring OBS right now. It's alright. I'll just ignore it. Yeah, that it is kind of loud. It's alright. Hopefully. Pre-commit hooks, 3.8, 3.2. Okay. Maybe I don't specify a rev. Okay, so it's a required key. Well, convert that. It's still a required key, alright. Okay, well that passed. Except why doesn't this work? Maybe 3.7. I know I'm just like testing out random shit right now. Maybe it doesn't matter all that much, to be honest. If it works, right? Python provider. Bro, go to YouTube and search your average tech bro and see his last third video. No, bro. Maybe. Okay, give me a sec. I'll check it out in a bit. After I just figure this thing out with VS Code, and I'll check it out. Search the Python formatting provider, set the value to black. Okay. Workspace settings. Well, that's not really... My god. Ooh. Why is this like GPT, to be honest? Okay. Yep. Sure. Trailing white space. Damn, the robo is going crazy, yeah. My bad. Alright, the average tech bro. Is this it? Is this the video you're talking about? What, you mean on the homepage? I'm guessing this is where you read about fuck, I forgot the name. Starts with C. I forgot the name of the app. Four row. Third video. Or is it 4 row? Third video. Which one is it? I'm guessing this one. Oh, right. Right, you can't see it because it's blocked. My bad. I was looking at this. I was like this or this. So this one, I see.
I've built 2 SaaS apps to $500 a month of recurring revenue, and in this video, I'm going to be pulling back the curtains on both of them to show everything about how I grew the app, showing you real Stripe revenue numbers, as well as other important metrics like number of users, retention.
Yeah.
So now if we go over to, let's go to our Stripe dashboard, you can see that...
Of course they're like, you know, this is all we care about, like MMR, click-through rates. I don't even know the exact metrics. Regardless.
This is the Nexus app, and you can see that currently I'm at around $450 of monthly recurring revenue. But what's even crazier, if you go to where I'm posting this website, which is forsell.com, you can see that I literally have not touched this app in forever. So it says 24 days ago was the last time that I touched this app, but really I was just redeploying this application to get a new environment variable out there. So really, I actually haven't touched this app in 70 days. It has been so long, and it kind of just prints money for me. It's actually insane. So You go look at the revenue, you can say I'm at around $450 of monthly recurring revenue. And in this year to date, which is pretty much the entire existence of this company, of this product, it has made roughly $2,600 total. So not life-changing money, not enough to like retire me by any means, but I'm not going to complain at a free $449 that come into my pocket every single month. So in terms of how I built this application, this is a Next.js application that is hosted on Vercel, like I showed here.
Yeah.
I'm using Next.js as my entire stack, front end and back end, I'm using Stripe as my payment processor. I actually have an existing video where I talk about my entire tech stack of what I use to build my applications, and this is exactly that. It is using the same exact tech stack that I talked about in the video. So it uses Scale as my database and back end.
Yeah, well, it makes sense, you know. You pick a tech stack that you are most familiar with to build every other app that you're thinking of building in existence. And that's, you know, basically the plan that most people like these guys follow as well. So it makes sense so far. Gosh damn, the robot is loud.
Make sure to watch that video for more details. And then in terms of how I grew this application,
What's the first part of the timestamp? Don't know which timestamp. Like what app he made. Yeah, okay.
so the very first app that I built is an app called NexusResearch.ai, which you can see right here. And it's essentially an AI-powered reading and note-taking tool. This was a very common tool.
AI-powered note-taking and reading tool.
Out there, it's one of those chat PDF tools where you essentially upload a PDF, and then from that uploaded PDF, you can then chat with it to extract any information that you want. Now, I will be the first to say, this is not the first product to come out in this space. I shamelessly copied or got inspiration from, I stole like an artist. Basically, I saw that this tool has proven market demand where people were building companies off of it and making a ton of money off of this type of idea. So I just leaned into it.
Yeah, like here's the thing. That's the thing, like you have to be on the trends with these apps. And I can get it, right? But I don't think I'm quick enough to get onto the trends of these types of apps and build them out like he has. And that's almost like, if you've heard about drop shipping, it's pretty much like you got to be on the trend always. You know, you got to be on LinkedIn probably for finding a SaaS app that people want, you know, and doing all this extra work when you know there's like the only fulfilling meaning is to get 2K a month as recurring revenue. I don't think that justifies it for me, because at the end of the day, the app is going to be abandoned and it's just going to be like, we're good, we're done with the app, you know, this is all it is. There's no future benefit apart from what you're getting from monthly recurring revenue. And obviously over time it'll falter, and it isn't just like a single point in time that, oh, I get $2,000, and I'm like, I'm good for the rest of my life, because it's not. You know, people fall out of the hype for specific apps, and they can fall out of it pretty fast. So one more thing, Levels.io X bio. Alright, fine. I'll check this. Yeah, I'll check this out because you said earlier. Alright, I have to go in 5 minutes, but let's quickly check this out, alright? I see what you mean. So when I thought you meant X bio, I thought it was like a collaboration. But you're talking about actually the bio of on Twitter. Okay, host list 0, 1K, 2K, photos AI 157K per month. Fair enough, you know. Oh, I'm being blocked. photoai.com. Let me just search that up. Fire your photographer, take stunning photos of people, the first AI photographer. Upload selfies and create your own Flux TM AI model. Take 100% AI photos in any pose, place or action. Try and close on your models, create 100% AI videos, run photo packs and AI yearbook in all menus. Right, so okay. So say you're saying you get these 4 photos and you make them into one. Midjourney 3. This is like, what's the name? I forgot her name. Doesn't matter. I forgot her name, but it doesn't matter. Like it's been a long time for these apps and the revenue is going. Yeah. Fair enough. Most detailed AI image generator for people. I mean, you can tell that. I mean, look at that. What's okay? Okay, it's alright. No, it's alright. AI makeup, lingerie. Of course, there's gonna be people like this. AI girlfriend. 1x ran this week. 1x ran this week. 2x ran this week. So people are just making this. The fact that these are all like, and look at this image, bruh. Pick from 55 photo packs. Yeah. Right. Yeah. I mean, I'm just looking into detail of one of these now. But yeah, I mean, I can see how he's getting 157k recurring revenue per month. Nomads though. Nomads. Alright, let me just quickly check on Nomads. Well, actually, nomads.com. Yeah, similar looking site, you know. Sure, yeah. Yeah, there's way more to it than, you know, than meets the eye. But yeah, damn. You know, fair enough. It's his only one app revenue, like it's insane. And they are working on it and providing updates monthly, daily as well. With all the freedom and peace. Yep. It's pretty good. I won't lie, you know, like this guy is in the weeds, but he's also like, you know, making the bank with this stuff. So, and his book is 67k per month. Yeah. Anyway, all right, I'm gonna call it a night for this stream. This stream will come back online later in the day. But thanks for being here, Zahid, especially. You know, you've been chatting the whole time. Feels like I have company with me, so it's all good. Yeah, right, yeah. So, like, you work in big tech companies and get paid this much, and you get overworked as well. But yeah. So, you know, over time, when I'm more skilled, the idea is something like this, but also not exactly, because I still have some values in my personal life that I want to follow, and something such as creating an AI girlfriend is not something on my mind as something morally just. But yeah, all right. You know, respect the hustle, definitely. And yeah, all right. Well, I'll call it a stream for now. I'll be back later after I've had like made lunch, gone to the gym, had a shower, come back, and yeah. All right. Have a great night, Zahib. Hope you finally get some sleep now. Catch ya.